Thank you. So just for fun, the thing that happened with the police here was they knocked at my door in my hotel room at 1:30 in the morning. They were looking for David Jeremy Harris, who's apparently committed a crime. Fortunately, I'm David Robert Harris, so I'm still here to be able to present instead of in a Spanish prison or jail. So, all right. So I'm David Harris. I'm the founder and CEO of Green Arrow Email. I've been working full-time in email since 2003, so 23 years, dating myself a little bit here. So at Green Arrow, we sell both an on-prem MTA that's used by some of the largest email service providers in the world, and we provide a fully managed email sending API service. It's also used by ESPs and large senders. So we live and breathe email. It's what we do. I love email. This is a great industry. So the first time I came to Europe, I saw this exit sign. I actually took this picture on my first day in Europe. At first, I didn't understand this sign. Was it like, run this way? I didn't see the white background as a door. It didn't connect. And like green means like good and not like danger. So the exit sign, this is the exit signs of what I'm used to in the United States. You know, red fits with danger. It's spelled out. It's not a pictogram. But once I understood these European exit signs, you know, I really like them. Saw this one a few days later, and this kind of amused me, like, man running to big block of marble. I don't know exactly what's going on here. But, you know, once you understand it, it makes sense. But then at the baggage claim at the airport here, I saw the largest exit sign I've ever seen. You know, this is like, I mean, almost like life-sized, you know, human figure running towards exit. And then they had a ton of them. So why are we talking about exit signs? You're probably asking yourself that question. The point is, if there's a fire in a building, it's a life safety issue to know the path to get to the exit, especially if there's smoke. But not only do you need to know where the exit is, the exit needs to be unlocked when you get there. So which is why we put these crash bars on doors that you see pictured here. So you can't lock the door and keep people inside, which is also a life safety issue. So this has given rise to the saying among software companies, don't block the exit. Meaning that if you make it easier for people to export your data or leave your service, you also make it easier and safer for them to become your customer in the first place. So one company in our space that notably has this as a core value is HubSpot. So what are we talking about today? Specifically, we're going to talk about how to make sure that your exits aren't locked if you're an email service provider, that you're not locked in. So the first stop is going to be avoiding DNS lock-in for ESPs that are using an email API service. So this is an ESP, delivers email on behalf of their customers who we're going to call brands in this talk. The ESP is using a back-end email API service. Now they will have to have their brands configured DNS, and we're going to show you how to do that so as the ESP you're not locked into that particular back-end service. And this is something that's really resonated with ESPs that we're talking to, and we're going to show you how to actually do it in this talk. Second stop, future-proofing DNS. If you're an ESP running an on-prem MTA, some of the same techniques we're going to talk about are going to be useful for you. How you can have your customers set up DNS so that you're future-proofed. If you ever need to make any DNS updates, you don't have to go back to the customers and ask them to do that, because we all know that goes really well, and it's easy. So like maybe you're going to have to change DKIM key sizes, or future DMARC policy updates required, or maybe some aggregate statistics reporting is going to require a DNS record. Ultimately, we don't know. The third stop is we're going to briefly look at data from a real-life migration. Because the whole point of this is you want to be able to change providers, and migrations can be scary, so we're going to kind of de-risk that or demystify it just a little bit. So there's a saying, the best time to plant a tree was 20 years ago. And the second best time is, does anyone know the answer? Today. Yeah, the second best time to plant a tree is today. So you can't go back and prevent the lock-in that you've already created if you're an ESP. But you can stop digging the hole deeper today. And we're going to show you how to do that. So stop number one, avoiding DNS lock-in for ESPs that are using an email API service. So we've got three participants that are coming here onto the stage. First, you've got the brand. and they're in fashionable orange. They're the ones with the actual subscribers that have permission to send wanted and expected email. And we're going to look at some of the DNS records that they would be asked to set up. So we're going to use brand.example in the DNS, and we're going to color code it orange to make it easier to follow. In the middle, we have cool blue. That's the email service provider. They've got the web interface that the brand uses to create and schedule those emails. And in our DNS examples, they're going to be esp.example. And on the right in green, we've got that back-end email API service. So that's the SparkPost, SendGrid, Mailgun, SES, Green Arrow Cloud, whatever service you're using. So the ESP hands off these individual emails to the back end to do the delivery. And the DNS records, they're going to be backend.example, and we're going to color code them green. So these arrows here show the vendor-customer relationships. So the brand is the ESP's customer, and the ESP is the backend's customer. So the brand wants to start sending email with a from header domain of e.brand.example. Kind of common thing. So email authentication needs to be set up, right? So we're going to keep the world safe, keep email safe. This is a good thing, which means that the ESP needs to tell the brand to set up DNS. And that's not always so easy. And that's kind of a pain. So we're going to talk about how to make that less painful. So this is the typical an example of what the DNS that an ESP might give a brand to be able to set up. So you guys have all probably seen this kind of thing before. The first record is the DKIM public key. Now we've labeled it green because it's typically locked into the backend provider. They don't let you export the DKIM key, or the private key. The next two records support using the send.e.brand.example hostname as your SMTP mail from domain in order to use for bounce processing that the backend provider is doing. And the last is a DMARC record that we're all familiar with. So pretty standard stuff. But what's wrong here? Oops, that's the wrong way. All right, what's wrong here? There's no ESP. The blue there's no blue in this. The ESP has been left out of the party. Now, that creates the vendor lock-in. So what we've done is this. We've directly connected the back end to the brand. Now, this looks like a smiley face, but it's not a happy thing. So what we'd rather have is the brand connected to the ESP, and then the ESP connected to the back end, which puts the ESP in control, allows them to, if they want to, they could set up another back end, they could use multiple back ends, they could migrate back ends. So how do we do this? That is the question that we are going to talk about. So we got 4 ways that you can do this that we're going to discuss. And there are other ways or ways to combine these, but these are the most common paths. All right, so the first one is using CNAMEs. So the basic thing that's going to go on here is that the brand is going to create a CNAME record pointing to another host name. But that host name is going to have all the DNS that the backend needs in order to deliver the email. But that host name is controlled by the ESP, and therefore the ESP has the ability to update the DNS. So what does that look like in practice? So remember, our first record was the DKIM public key that the ESP was going to ask the brand to create. So instead of the brand directly creating the text record with the public key in it, what you just do instead is you have the brand create a CNAME to a host name that's controlled by the email service provider. And that is pointing to a text record that actually has the public key where it can be found. So the CNAME record says, basically, go look over here. You'll find what you need over there. So when the DKIM library needs to validate the key, it looks in the normal place, sees the CNAME, follows that, looks up the other record, gets the key, everything works as per normal. So let's break down this host name. So the first one, ESP dot, that's just the selector name. So usually ESP has customized that with their name in the selector. Then the 8CB40D in purple, the hex characters, those are just a unique identifier that's created for each customer of the ESP. Each brand is going to have their own. Typically, it's just randomly generated. And the ESP.example is the dynamic, where all that living. So you need to set up this with a dynamic DNS system requires some programming. You could use like Amazon Route 53, or Cloudflare has a DNS service. So when you're setting up a customer, you hit an API call to create the text record on the bottom in DNS. So we've mostly solved the problem here, but not quite all the way, because we need to have 2 DKIM keys. Because when you're migrating providers, you're going to need to send mail from both providers at the same time. So we just have 2 CNAMEs going to 2 different dynamic DNS records with the public keys. Now, this also gives you the ability to do DKIM key rotation. So 2 birds killed with 1 stone. So the next thing we need to deal with is that host name that was used for the SMTP mail from, sem.e.brand.example. So instead of having the brand create this DNS, we are going to do the same thing. We're going to replace it with a CNAME that points to that same DNS that's hosted in the dynamic DNS zone of the ESP. So this puts the ESP in control. They can update those records if they want. Now, in the same way that we needed 2 DKIM keys to be able to send 2 providers at the same time, if you ever want to be able to migrate, you also need 2 of these, because both providers are going to need to do their own bounce processing. And I forget, one of the earlier presentations, someone mentioned, each provider should have their own SMTP mail from hostname. And it doesn't really matter what the provider puts at that second record. We just put placeholder here. But what it does is it gives them the ability in the future to wire it into a second backend provider and migrate if they ever want. The last thing we have is the DMARC record. I think you can probably guess how we're going to handle this. DMARC also supports using CNAMEs, so you can just CNAME that into a dynamic DNS hostname. So this is what it all looks like when you put it together. First 2 records are the public keys. Next 2 records are your SMTP mail from domains. And then the last record is your DMARC. But if you notice here, we've solved the problem. Blue has joined the party, and green is not in this slide. So we've directly connected the brand to the email service provider. So this is, I gotta go back here. So this is almost exactly like the DNS that somebody using the Green Arrow Cloud MTA, if they're an ESP, will have them set up in order to set up a brand. So we've built the dynamic DNS system, and we can run all of that, and we'll run it under the ESP's hostname. So we'll have it, using their domain name. And if the ESP ever wants to migrate providers, they can just get all of the dynamic DNS records, export those, start running the dynamic DNS service themselves, and then they're in control of the whole picture. I figure it doesn't make sense for everybody to have to build the same thing. So the second method of the way to do this is NS delegation. So basically, DNS has a built-in way to delegate authority for a domain name and all of its subdomains to another DNS server. And this is done with the NS record. And this is one of the foundational things that allows DNS to be a distributed hierarchical system. And it's a little bit different than what the CNAMEs did for us. So the CNAMEs just a single host name, so go look over here and get the information. But an NS record delegates that host name and everything under it in order into the other DNS servers that are mentioned. So here's what it looks like. Just 2 records for e.brands.example. They're both NS records, and you point them to 2 different DNS servers. So the reason that you need 2 is it's a load balancing and redundancy method, and both of those need to be serving the same data. And if you're using a dynamic DNS service, you're just going to make one API call. They're going to serve the same data out of both DNS servers. However, there's an abuse vector that needs to be closed. We've just potentially created a big abuse vector if that's all we do. So nothing that the brand added to the DNS that we asked them to add proves that they're the particular owner of that domain name. So the problem is, if one user creates an account at an ESP, and they configure a from header domain, create the DNS records that we've asked them to create, these 2 NS records, and they verify the from header domain, But then sometime later, they cancel their account, and of course, they delete the DNS records. Well, actually, they're probably not going to delete the DNS records. Good chance they'll still be left there. So someone else could come along with the same ESP, create a new account, enter the same from header domain, and, oh, look, it's verified. The DNS that we asked you to create is already there. Good job. You can send email for that domain name. That's the abuse vector. So when we were asking the customers to enter the DKIM private key, or those C names that had that purple dynamic host name in them, that unique value we gave to the user was acting like a security authorization, proving that, okay, the person we gave that information to had the ability to update DNS. So it's pretty simple to solve the problem. You need to add another DNS record, typically a text record, and you're going to put it in brand.example, not inside of e.brand.example. And then it's going to have a unique value that you randomly generate for each user. And it provides the company that you gave it to the opportunity to prove that, yes, they're the ones that have the ability to update DNS. They're probably the owner of the domain name. And in ESP, you're going to put your own ESP name in there. So compared to C names, NS delegation, it's got some advantages. So there's less DNS records. It's only 3 instead of 5. It's more future-proof because it delegates that domain name and everything under it. So if you ever want to create another host name under e.brand.example, you can do it. However, it's got a couple of disadvantages. So it's not supported by all DNS providers. Some of them won't let you add NS records. Some security departments, corporate security departments, aren't going to allow it because it lets you do anything you want under that domain name, and they don't want you to do that. But the total future-proofing and flexibility provided by the NS delegation has a lot of value. But you're going to have to support C names as a fallback because not all of your customers are going to be able to do NS delegation. So the third option here we've got is DKIM key archiving and wildcard DNS. So the other options we talked about required a non-negligible amount of software development, creating those dynamic DNS host names, setting up a dynamic DNS zone. But this is a technique that maybe you could implement sooner with a lot less development work. So remember, we had 3 kind of problems we had to solve in order to solve the lock-in. The first was the DKIM key. So the problem here is that most back-end providers don't let you export the DKIM private key. And that's could be part of a lock-in strategy. So it's Hotel California. You can check in, but you can't check out. But they let you import a DKIM key. And that gives you what you need to be able to escape the lock-in. Because what you can do is you just create the DKIM public key, private key pair yourself, archive the private key, send that to them when you create the setup, and now you import that to the backend provider. Now you own the private key, and you're in control as the email service provider. And if you ever want to change to another provider, you could import that same private key to the other provider. So the second problem we had was the host name for the SMTP mail from. They had the MX and the SPF record. So we're also going to solve this with a C name, but we're going to do it just a little bit differently. So this is like we did before, but you see that purple identifier, the hex characters? We've moved it to the left edge of the host name because that allows us to use wildcard DNS. So you can set up a record star.send.esp.example that just basically says anything under that, answer with these records. Unfortunately, the MX and the text record that needs to be created is the same for every customer, so you can use the wildcard DNS. Still gives you the ability as the ESP in the future, you can create more specific DNS records that will override the wildcard, and you can override each individual customer, which backend you want to tie them to, but you can do that work in the future. So putting it all together, this is what it would look like to use that strategy. You've got the public key, and we've labeled it blue because we've avoided lock-in by archiving the private key. And you're going to need 2 host names for SMTP mail from to give you the ability to migrate in the future and run 2 providers at the same time. Those both CNAME to dynamic or wildcard DNS host names with a unique value on the left. And then the last is the DMARC record. So we're just not going to CNAME this here just to keep it simple. You could if you want. The fourth strategy we've got is DKIM key archiving with SPF includes. So this is a real-life example from a major ESP. So they're using a shared domain for the SMTP mail from. And so this simplifies how we would set up the DNS to avoid lock-in. So here's what the DNS records that the customer or the brand is being asked to set up. So the first record is the public key, just as like you'd expect. Second record is just an SPF record. And the third is the DMARC record. Now, but you might notice there's no MX record here. So it's not actually possible to use send.e.brand example as the SMTP mail from. So the second DNS record is actually unnecessary, except for the fact that the backend provider is asking it to be created. So it does need to be created there. So what we can do, so first we're going to archive the DKIM public key, create it on our own, import it. And the second thing we're going to do is we're going to change that SPF record. Instead of including the backend provider, we're just going to include an ESP's host name. And then that host name is going to then include the backend provider. So keep this under 10 total DNS lookups and you're fine, but we've really just added one to the chain here. And that's enough to keep the ESP from locking in their customers to that backend. So stop number 2, future-proofing DNS for ESPs that are using an on-prem MTA. So everything we've talked about so far may have only sounded like it applies to ESPs that are using one of those back-end email API services. But these same techniques are useful for on-prem ESPs to future-proof against future needs to update DNS. So the heart of the matter is really the ESP having the flexibility to update DNS without having to ask the brand to do anything. Maybe there's going to be some future change required to DMARC. Or maybe mailbox provider aggregate reporting statistics is going to require a DNS record. Who knows? The point is we don't know the future, but we can be prepared. So both CNAMEs and NS delegation can be employed by an on-prem ESP to future-proof. So remember, CNAMEs, there's limited flexibility. You can only update the existing records that you've got. But NS delegation, fully future-proof. You can update or create any record inside that zone. It's not supported or allowed by all brands, so you're going to have to support CNAMEs as a backup. All right, so stop number 3. I'm going to show you some data from a real-life ESP migration because migrating can be scary. You don't want to hurt your email deliverability. Email deliverability can sometimes feel like a mystery. So any kind of change is scary. And need to remember, things are always changing all the time anyway. And this is a change that can be scientifically managed and de-risked. All right. So the keys are you need to go slowly and you need to start small. So you're going to want to send just a small amount of email with your new vendor. Such that if there's an email deliverability problem, it's not going to hurt you overall because it's such a small percentage of your total traffic. And then you can compare the stats between the old system and the new system and simply compare the open rates between the two and see, is there parity? And yes, both of these include, MPP opens, bot opens, all of that stuff, but you're comparing apples to apples. It's open rates of statistically identical mail just sent with a different provider, with the same from header domain. So you can scientifically validate that your deliverability is being maintained with the migration. And there's a number of reporting consoles, such as the Postmastery console. It sounds like Easy DMARC is getting into that as well, that can take webhook data from your different backends, allowing you to easily compare the data. So you don't even have to build the reporting for that if you don't want. And even if you do the migration starting with engaged traffic first to warm up the new system, you can send 2 small portions of traffic through the old system and the new system that you exempt from that engagement-based warm-up system and use those for your purposes of your comparison. So you can move forward with confidence and validate as you go. So another thing that's helpful is partner with an experienced vendor. So you may have not done one of these migrations before, but it's very likely your vendor has, and they can share their experience and help you through it. Or there's third-party consulting companies that they've done it as well, and they can walk you through doing a migration. So here's a graph of an actual ESP migration. The full case study is on our blog if you're interested. Each data point on the x-axis is a week. And so let's start with the bottom chart. Let me explain what's going on. So the red line is the percentage of email that was sent on the new system. The blue bars are the total aggregate number of messages that were sent on the new system. The top blue line is that relative open rate comparison statistic I mentioned. So 100% means open rates on both systems are identical. 200% would mean the new system has double the open rate. 50% means the new system has half the open rate. So close to 100% is what you want. That means everything's been maintained. So as you can see on the right, we ended up at just above 100%, but basically the same. So the first week in here, just 1.6% of traffic, or percent of email sent, and as you would expect with no reputation already built, 74.6%, it was the relative open rate, so performed worse on the new system just because it was starting to warm up and build reputation. But very minimal effect on the customers because only 1.6% of the actual total email was being sent, so very negligible effect that any brand could see. And then by the second and third weeks, the relative results were improved. And actually the second week was really the first week of sending for some of the brands in the migration. But by the time everybody's been on a second week, the relative rates are above 100%. So meaning the new system's performing slightly better. But then there was a hiccup on the week of 5/11. You notice that the relative goes down to 86.4%. And there's actually a reason for that you can see in this chart. So on the bottom, even though the percentage of email went from 23.3 to 29%, the blue bar, it doubled. So this came from a particularly large campaign going out, and so the warm-up went faster than it should have, and of course the results go down because you build your reputation at a certain level of volume. So once you've built a reputation, you need to slowly ramp up. So we slowed everything down over the next few weeks, and then the rest was above 100%. So we talk about, Todd mentioned this earlier, brands get the deliverability that they deserve. And this really shows this, that the brands basically got the same deliverability on the new system. It's because the deliverability is determined by their practices, the fundamentals of their email program. So the whole point of this talk is to help you make sure that your exits are not locked and allow you to future-proof DNS. And remember that the second best time to plant a tree is today. You can't do anything about the lock-in that's already happened, but you can stop locking in your additional customers. All right, so that's what we got. Do you have any questions? All right, thank you.
Do we have time for questions? I think we have about 2 minutes, so maybe 1 or 2 questions.
Hi. I was wondering if you heard about, I don't know how to pronounce it, SHA or SHA, S-H-A, on DKIM. It's a new RFC, basically. Okay, well,
yeah, I'm not familiar with that.
Okay, so I won't ask a question about it.
Okay. Richard, if it's about DKIM, he might be the one to ask. He's next.
DKIM.
Mainly the question was, do you recommend implementation of it? Because it's, well, it's a new RFC, and basically, yeah, well, that would be it if you know, yeah.
I don't have an opinion on that.
Okay, thanks.
1 more question, maybe? No? Do we have anybody? I think you're good.
All right, great. Thank you.
Thank you.